皆様、こんにちは。インド工科大学ハイデラバード校のセミナーにご参加いただき、大変ありがとうございます。本日は世界のトップエンジニアが集うインド工科大学ハイデラバード校優秀な人材採用トップレベルの頭脳との共同研究のチャンスをつかめと題しまして、インド工科大学ハイデラバード校との産学共同研究など連携へのお誘いをさせていただきたくお話を申し上げます。私は JICA フレンドシップ 2.0 プロジェクトの斉藤と申します。どうぞよろしくお願いいたします。日本はこのインド工科大学ハイデラバード校 IITH と呼んでいますが、こちらのキャンパスの整備や日本との連携促進など様々な支援を行っていて、インドに23校あるインド工科大学の中では一番日本に近い大学となっています。JICA フレンドシップ 2.0 プロジェクトはそうした支援の一つです。本日はこれからどうぞよろしくお願いいたします。
本日のセミナーではこちらにスライドに記載の通り、私からインド工科大学ハイデラバード校 IITH と日本との連携を支援する JICA 国際協力機構の実施しているフレンドシッププロジェクトのご紹介をさせていただき、続いて IITH を代表して学長のムルティ博士からのご挨拶、その後にフレンドシップ 2.0 の共同研究グラントで現在日本企業と研究を実施している4つの事例をご紹介する予定です。日本企業との研究事例4つご紹介いたしますが、まず1つ目は大気アクシスインド様と IITH のデブラジ博士との研究で、静岡大学様もチームに加わり、日本の浄化槽をインドの環境により適合させるための研究です。2つ目はサイエントラブス合同会社様と IITH のガジェンドラナス博士との心電図モニタリングに関する研究です。この研究の概要は日本側の企業であるサイエントラブス様のチャイタニア社長に説明していただきます。3つ目はファインエコソリューション株式会社様と IITH のスレンダラ博士とのパウチ型リチウムイオン電池に関する研究です。最後の4つ目は株式会社フローリック様と IITH のスーリア博士とのコンクリートの多機能化学混和剤に関する研究です。いずれの研究も最近スタートしたところですので、今日のセミナーでは研究の目的や概要などのご説明をお聞きいただきます。IITH では教員1人が研究するのではなく、研究室の学生やポスドクがチームとなって研究に携わっています。本日のこれからの研究概要のご紹介でも、そうした学生さんなどのメンバーも説明をしてくれています。共同研究を通して、そうした研究室の優秀な人材へのコンタクトも可能になります。ぜひ御社も IITH との共同研究の可能性についてご検討いただければ幸いです。また今日お話しさせていただく研究内容のご紹介を現地の展示ブースでも行っておりますので、そちらもぜひ合わせてご訪問いただければ幸いです。私どもは NEXT GENERATION PARK 去年までのスタートアップ&ユニバーシティの会場にブースがございます。それではまずはじめに IIT ハイデラバード校 IITH と日本との連携を支援している JICA フレンドシップ 2.0 プロジェクトについて簡単にご紹介いたします。本プロジェクトは私の所属する株式会社パデコを中心としたメンバーが JICA の技術協力プロジェクトとして実施しているものです。2021年の12月から5年半の予定で実施しています。本プロジェクトは IITH と日本の大学、研究機関、そして企業様との持続的なプラットフォームを構築することを目的とし、主に3つの領域で活動を展開しています。1つは日本との連携のハブとなる IITH 内に設置されているジャパンデスクの強化、そして2つ目は日本への留学生奨学金の提供、そして3つ目は日本との共同研究の資金の提供です。なお現段階では企業様との連携を促進する研究資金の募集は終了していて、現在実施中の研究をモニターしている状況です。なお一番下に記載をしていますが、このプロジェクトの前に2012年から第1フェーズとして同様のフレンドシップ 1.0 プロジェクトが実施されていました。この時にはまずは IITH と日本との連携のきっかけを作るべく多くの人的交流を支援しました。IITH からの留学生は116名、IITH 教員153名の来日交流と119名の本邦大学教員の IITH 訪問といった相互交流などを支援しました。こうした実績の上に第2フェーズであるフレンドシップ 2.0 プロジェクトは日本との連携をより継続的なものにするべく IITH ジャパンデスクの支援等の活動を行っているものです。 ここで改めまして日本の産業界の皆様の本プロジェクトへのご理解とご支援に厚くお礼申し上げます。それではここでインド工科大学ハイデラバード校についての簡単なご紹介を申し上げます。IITH は2008年に設立されたインド国内に23校あるインド工科大学のいわゆる第2世代の大学です。インド教育省のナショナルインスティテューショナルランキングフレームワークの工学分野のランキングではインド国内の工学分野の高等教育機関として第8位に、またイノベーション分野ではインド国内で第3位にランキングされていて、IIT デリーやボンベイといった第一世代の伝統校に肩を並べています。また最新の数字を見てみますと、教員数は約300名を超え、その平均年齢は40歳を切る非常に若い先生が中心でアグレッシブな活動が展開されていることが特徴です。学生数は4700人を超え、特許出願や論文発表なども活発です。さらにインド経済と同様にまだまだ急成長している大学です。またこれまでのフレンドシッププロジェクトの支援により、日本の産業界、学術界との連携も進んでいます。さて、こちらのスライドに日本とのこれまでの連携実績をまとめました。日本企業への就職実績ですが、これまでに200名以上が日本企業に就職しました。楽天グループ様、NTT様、アクセンチュアジャパン様、鈴木様、富士通様などが過去の実績人数では上位を占めていますが、それ以外にも多くの企業様に採用していただきました。日本企業へのインターンシップ実績は累計で80名以上が様々な企業に受け入れていただきました。日本でのインターンシップやオンラインでのインターンシップがありました。日本企業との連携協定は累計で20社以上。日本企業との共同教育プログラムについては、現在いくつか準備中ですが、その中の一つとして、ルネサスエレクトロニクス株式会社様と MOU を結び、半導体に関する教育が IITH のカリキュラムとして共同で間もなく開始されることになっています。日本企業との共同研究は、フレンドシップ 2.0 プロジェクトが資金を提供しているものを含め、現在5件進行中ですが、加えて教員レベルでの日本企業との共同研究もさらにいくつか展開されています。日本国内の学術協定先はニムス国立研究開発法人物質材料研究開発機構様など4つの研究機関、また日本国内学術協定校は現在15大学となっています。さらにこうした連携が日々拡大しています。さて、ここで日本の産業界が IITH と連携するベネフィットについて少し触れさせていただきます。まずは IITH の広い研究分野が挙げられます。インドと言いますと IT や AI といった印象が強いかと思いますが、インドは科学技術分野全般において発展しています。IITH ではスライドの記載の通り、工学科学の領域だけでも15の学科を有しています。また IITH で学ぶ知識とモチベーションに富んだ優秀な学生は日本企業の人材としては大きく期待されています。毎年まとめられているスタンフォードトップ 2% サイエンティストリストにも IITH の研究者が多くランクインしていて、2023年にはシングルイヤーベーストで25名の研究者が掲載されました。そのランクインした研究者を見ると IITH は化学や材料科学の領域も強いことがわかります。ここで日本企業の皆様にぜひご紹介したいことがございます。IITH ではインダストリーレクチャーといって、現在企業からの講義を取り入れ、学生の産業界への関心を高める取り組みを開始しています。20以上の様々な工学系の修士プログラムで導入されていて、次回は2025年の1月から始まる予定です。企業様はオンラインまたは IITH に来ていただき対面で、60分のセッションを1コマご担当いただくのですが、その中で企業の経営方針や戦略、ビジネスの概要、特定の技術の紹介等、自由に設定でき、質疑応答を入れて60分のセッションをしていただくものです。また、希望により学生にプロジェクトを課すことも可能です。これは本プロジェクトから資金的な支援を行うものではなく、また IITH からも謝礼や必要経費などは出ません。記者の IITH 学生の広報の一環、または IITH 研究者との交流のきっかけとしてご検討いただければ幸いです。ご関心がございましたら、ぜひジャパンデスクまでお問い合わせいただくか、展示ブース担当者にお声掛けいただきましたら、詳しくご説明させていただきます。 ぜひ IITH の学生を知るきっかけに、インドへの足がかりの一環としてご検討いただければ幸いです。私からのお話の最後に IITH の中に設置されているジャパンデスクをご紹介いたします。IITH と日本の産業界との連携のワンストップサービス窓口として様々なサービスを展開していくべく、現在私どもフレンドシップ 2.0 プロジェクトが強力に支援しています。本大学についてのお問い合わせなど、まずはジャパンデスクにお声掛けいただければ対応させていただきます。ぜひ IITH との連携をご検討いただければ幸いです。それでは最後にジャパンデスクの紹介ビデオ、2分ほどの動画になりますが、ご覧いただけますでしょうか。
I'm Sangeeta Srivastava, Project Administrator for Friendship 2.0 project. I'm supporting IITH faculty and JICA project team for the joint research grant.
Konnichiwa, my friends from Japan. IIT Hyderabad has a very unique relationship with Japan through its inception from 2008. To facilitate this, we have established Japan Desk. And Japan Desk provides a one-step service to the Japan for industrial and academic collaborations. Me, along with my team, welcome all of you at IIT Hyderabad.
それではこれで私からのご紹介を終わらせていただきます。どうもありがとうございました。では続けて日本企業との4つの共同研究をご紹介してまいります。どうぞ続けてご覧ください。
Good morning, friends. Konnichiwa. Welcome to this interaction with all of you from IIT Hyderabad. I am Professor B.S. Murty, Director of IIT Hyderabad. As you all might know, India has a number of IITs which are called Indian Institute of Technologies. There are 23 of them starting from 1951 and until 2015. These 23 IITs came in a number of phases. We call them as three phases. The first phase of IITs came particularly in 50s and early 60s. And then another phase of IITs came in 2008. And a third phase of IITs called third generation IITs came in 2014-15. That's how today we have 23 IITs. IIT Hyderabad is known to be a second generation IIT, which has come up in 2008 along with 7 other IITs. And if you look at IIT Hyderabad as it stands today, in the last 15 years, we have grown strength to strength to be almost on par with even the first generation IITs. Among the second generation IITs, IIT Hyderabad stands as number 1 in every parameter that people look at. India has started giving ranking to the institutions for the last 8 years. These are called NIRF rankings, National Institutional Ranking Framework it is called. And in these rankings, IIT Hyderabad has always been in the top 10 engineering institutions in the country. And for the last few years, we have been maintaining 8th rank just immediately after the first 7 first-generation IITs. Recently, Indian government has also started ranking institutions based on innovations that are happening at those institutions, and IIT Hyderabad is being ranked as 3rd rank in innovation. IIT Hyderabad, for your information, if you go to our website, we say our philosophy is inventing and innovating in technology for humanity. For all of us at IIT Hyderabad, IITH stands for inventing and innovating in technology for humanity, not simply Indian Institute of Technology Hyderabad. And that's there in our blood, that's there in our motto, and that's our philosophy, because of which we have been trying to bring variety of innovations in various fronts. I will talk about these innovations a little later. First, let me also talk about our friendship with Japan. IIT Hyderabad has a very unique position among all the IITs in India that Japan has chosen IIT Hyderabad to collaborate very strongly and with a program supported by JICA, Japan International Collaboration Agency, which has given a soft loan to Government of India to set up the phase 2 part of the IIT Hyderabad infrastructure, which comes to close to around 1,500 crores of Indian rupees. And with that, a number of research academic buildings and research buildings have been set up. And also there has been some funding even for research facilities to be set up. On top of all this, we have what is called a friendship program of a strong collaboration with Japanese universities and IIT Hyderabad, so that a large number of IIT Hyderabad students were able to go to Japanese universities, do their masters and PhD. Similarly, a large number of faculty members from IIT Hyderabad got exchanged to various universities in Japan, and a number of faculty and students from Japan regularly keep coming to IIT Hyderabad under this friendship program, which has already completed its phase 1. From 2012 to 2021, we had the phase 1 of the friendship program, and right now we are into phase 2 of the friendship program, where we are trying to strengthen this collaboration further with more and more collaborations and more joint research. Not only publishing papers together, but publishing patents together and ensuring that our students from both the sides have jointly supervised PhDs being done by professors from both the universities coming together. A professor of, for example, a Kyoto University and a professor of IIT Hyderabad jointly supervising a student, so that the student finally submits the PhD thesis under the joint guidance of both the professors is something, a unique feature which a large number of students from both the sides are taking advantage of. And this is leading to a large number of publications and large number of patents coming out. We are also trying to see that our collaborations are not only with the universities, but also with industry. A large number of industry projects are also being taken, and a number of industries are coming to IIT Hyderabad, even taking space in IIT Hyderabad on our campus to collaborate more strongly with us. IIT Hyderabad, one of the buildings that has been set up in the last few years is called TRP, Technology Research Park, where any industry can take a space there and collaborate with IIT Hyderabad. A number of Japanese industries are taking space in this TRP, and one such example I can quote is our Suzuki Motor Corporation, which has taken up almost 3,000 square foot area where they have set up something called Suzuki Innovation Center, which is the only R&D center of Suzuki Motor Corporation outside Japan anywhere in the world. And that's sitting at IIT Hyderabad, and a strong collaboration in the area of automobiles, particularly future generation of automobiles such as autonomous navigation and other advanced technologies. Professors of IIT Hyderabad and Suzuki Motor Corporation, through what is called Suzuki Innovation Center. Suzuki Innovation Center is also doing a lot of work in the area of rural development, supporting the number of villages near IIT Hyderabad through our what is called Rural Development Center that IIT Hyderabad has. IIT Hyderabad has adopted about 5 villages nearby, and Suzuki Innovation Center has been working closely with these villages. In addition, Suzuki Motor Corporation through Next Bharat Ventures, which is a recent venture that has come out of Suzuki Motor Corporation, is also trying to set up a skill development center at IIT Hyderabad to skill people all around the villages near to IIT Hyderabad to see that they become skilled enough to be absorbed by MSMEs in India and also possibly anywhere outside the country also. So these are all various collaborations that are happening at IIT Hyderabad thanks to such a strong collaborations ecosystem that IIT Hyderabad and Japan has established. In fact, every year Japanese industries come to IIT Hyderabad and recruit our students, and the number of students being recruited year after year is continuously increasing. Just to give you an example, this year in the month of March, I visited Tokyo and went to Hamamatsu to the Suzuki Motor Corporation headquarters, and I had a lunch with 25 of our IIT Hyderabad alumni who are working in Suzuki Motor Corporation. Possibly this is the largest number of any IIT students working in any Japanese company in Japan. So that tells you how strong is our population in Japanese industry. In addition, in Tokyo itself, IIT Hyderabad alumni are more than 200 who are staying there, working with a number of industries in Japan, and also some of them are also doing their PhD and masters in some of the universities. This is the kind of culture that is being set up and an ecosystem that is being built between IIT Hyderabad and Japanese industries and universities. In fact, this Japan Day that we call every year, where Japanese industries come and try to recruit our students, we have converted last year into Japan Week, and we are continuing that tradition even this year also, where not only industries come, but also a number of university heads come to IIT Hyderabad and interact with our faculty and students and try to look for future collaborations and strengthening the existing collaborations. All this is a strong ecosystem that has been developed thanks to the support that JICA has started with. And now this has been extended to JST. JST is also strongly supporting IIT Hyderabad with a number of collaborations with academic institutions. In addition, also we have what is called GISTEC is also supporting a lot of activities of IIT Hyderabad with Japanese industry. In fact, we also have MOUs with a number of Japanese universities, and we have also set up something called NIMS and IIT Hyderabad R&D Center at IIT Hyderabad, which is taking the PhD students and faculty members of IIT Hyderabad to NIMS, which is one of the best R&D labs in Japan, in Tsukuba, and strengthening our collaboration with the scientists of NIMS, where joint research supervision is going on. This has been going on for the last 3 years, and we expect that this will grow more and more in the years to come. So all these opportunities are now available, and we would like to see more and more of collaborations happening. In addition to the collaborations, we are also open to startup ecosystem. Okay, we would like to see more and more of joint startups with IIT Hyderabad and Japanese industry, supported students, particularly of Japan, working together with students of IIT Hyderabad and coming up with innovative ideas, which are joint innovative ideas and joint startups. We would like to see this happening more and more. And we expect Japanese industry and Indian industry to come forward to support this kind of joint innovations. At IIT Hyderabad, we have a program called BUILD program, which is called Bold and Unique Ideas Leading to Development. is a program where we support our students through funding and through mentorship, and a building that we have recently constructed, which is called TIP, Technology Innovation Park, with about 150,000 square foot area, where we provide space to any one of our students who have some innovative ideas so that they can come up with a product out of it. In fact, we also have a number of academic programs that we have started, which are more product oriented and innovation oriented programs. One such program is called Medical Device Innovation, a master's program on medical device innovation, where a student spends 4 months in the hospital, and at the end of spending time with the patients and doctors, identifies one problem which is concerning the patients and doctors. And at the end of the 2-year master's program, the student comes up with a prototype of a medical device. In addition, we have a department of entrepreneurship, which offers an MTech in what is called techno-entrepreneurship, where one engineering faculty and a science faculty, together with one entrepreneurship faculty, work together jointly and guide and supervise a student. And at the end of the 2-year program, the student not only comes up with a product, but also comes up with a business model for that product. So the engineering and science faculty teach the student how to make a product, and the entrepreneurship faculty teach them how to sell a product, for example. So this is another very innovative program which for the first time in the country we have started at IIT Hyderabad. So all these programs can be supported through our Japanese collaborations, and we would like to see more and more of such support happening through our friendship program. In addition, we also have a possibility of our students spending time in industries in Japan, for example, through a program that we call it as semester-long internship. IIT Hyderabad is one of the very few IITs in the country which has a semester-long internship program, where a student can go to any company, spend almost 6 to 7 months during the semester, and this is a accredited internship program. At the end of the 6 months program, when the student comes back, submits a report, he gets some credits of 6 credits for that particular internship. In addition, we have master's programs where a student is bound to do one year of what is called thesis, and we are now trying to allow these students in the last few years to go to an industry and stay there for almost 1 year and do a thesis work based on an industry-defined problems. Right now, I can confidently say that almost 50% of IIT Hyderabad students are doing their master's thesis on industry-defined problems rather than an academic-defined problems. Okay, so this is something which is very unique, and we also have what is called industry lectures as a 1-credit course at IIT Hyderabad. We would love to have more and more Japanese industries sparing their time to give a 1 hour or a 2 hour lectures on what is exciting in their company as far as technology is concerned, so that our students can open up their eyes and pick up problems related to such kind of live industrial problems and do their master's thesis on such live problems. So we would like to support this. In addition, we also want to support the industries through outreach programs by coming up with certain certificate programs which are useful to industry. If you are interested in any knowledge to be shared by IIT Hyderabad to you on a specific area of your interest, for example, something on AI or something on IoT or anything that is on something on smart mobility, for example, we will be able to come up with certificate programs. If needed, even degree programs are possible to be offered. For example, we have started something called OAT, Open to All Teaching, where we have converted our classrooms into hybrid classrooms, and anybody in the world can register for these courses in an online mode and do a course with IIT Hyderabad by sitting at your own place. I would like to encourage industry people from Japan to take advantage of this and do these OAT courses so that they can upskill themselves and reskill themselves through such kind of a knowledge gathering sessions with IIT Hyderabad excellent faculty. We have almost 315 excellent faculty at IIT Hyderabad who have an average age of around 38 and a brilliant faculty and brilliant students at IIT Hyderabad are building IIT Hyderabad to a much greater level. And we would like to welcome you to join hands with IIT Hyderabad to see that we collaborate together and in a win-win mode, we strengthen both our countries and help both our countries to grow to much greater levels. Thank you very much for this opportunity, and I look forward to receiving you at IIT Hyderabad anytime you are visiting India. And please do come and see IIT Hyderabad and collaborate with IIT Hyderabad. As people say, seeing is believing, and I'm sure when you come to IIT Hyderabad, you will fall in love with IIT Hyderabad. I'm 200% sure about it, and I'm sure you will then start thinking of how to collaborate with IIT Hyderabad. And there are numerous ways of collaborating. I have already enumerated a few of them in front of you, but we are open to all kinds of collaborations. You can come up with another innovative idea of collaborating with IIT Hyderabad, and we are open to such new ideas from you. Thank you very much, friends. Konnichiwa.
Wastewater management is a significant challenge in India. On average, Class 1 cities and Class 2 towns generate about 75,000 million liters of wastewater every day. Out of this, only 26,000 million liters receive some form of treatment, and the rest are discharged into the environment as it is, thereby causing environmental pollution and health issues. A two-pronged strategy has been adopted to tackle this pressing issue. Number one, augmenting the centralized wastewater treatment infrastructure across the country. And number two, decentralizing wastewater treatment. It has been mandated in many cities that the gated communities must have in-situ plants for wastewater treatment and reuse. Several configurations and processes for decentralized wastewater treatment have been proposed and are available in the market. These processes are primarily based on waste activated sludge process, where wastewater treatment is carried out using heterotrophic microorganisms for which we need to supply oxygen or air, which makes the treatment process costly. Also, new discharge guidelines mandate significant nutrient removal to prevent eutrophication of the receiving water bodies. Multiple tanks are required to remove nutrients and organic carbon, making the treatment process complex. Therefore, we need cost-effective and simple technology to address this issue. At IIT Hyderabad, we have been working on algal bacterial hybrid systems. It is a wastewater treatment system that relies on algal bacterial syntrophic association. The scientific background of the technology is like this. In the presence of a suitable light source, microalgae perform photosynthesis and produce oxygen, which is utilized by heterotrophic microorganisms for mineralizing organic carbon into dissolved carbon dioxide and organic nitrogen into ammonia and then to nitrate. Microalgae utilize dissolved carbon dioxide, nitrate, and other minerals for cell synthesis. The excess biomass which is produced in the system as a byproduct is removed through sludge wasting. The hybrid system requires less energy input, has less carbon footprint, and can simultaneously remove organic carbon and nutrients in a single tank. In addition to organic carbon and nutrient removal from wastewater, we are increasingly concerned about emerging micropollutants in our aquatic systems and environment. These pollutants are primarily anthropogenic substances that are designed to be bioresistant. Common categories of environmental micropollutants are pharmaceutical and personal care products, pesticides, dyes, fire retardants, disinfection byproducts, etc. Accidental or unintentional release of these compounds in the environment can cause detrimental effect on aquatic life forms as well as humans. For example, The presence of antibiotics in environment can give rise to antibiotic-resistant genes and bacteria, and also antibiotic resistance in humans. In our research with Shizuoka University, we monitor micropollutants in aquatic systems and in treatment plants, and study the antibiotic-resistant aspect as well. Jokatsu is a decentralized wastewater treatment system that treats human waste from flush toilets and grey water from bathrooms, kitchen and other locations. Developed in Japan, this technology has been extensively deployed across Japan as a part of government policy. More than 26% of sewage in Japan is treated using Jokatsu technology. Over 8 million Jokatsu units are running successfully in Japan, and several million units have been installed in various other countries. Funded by the Japan International Cooperation Agency, IIT Hyderabad has embarked on collaborative research with Shizuoka University and Daiki Axis India, a subsidiary of Daiki Axis Japan, to address wastewater management issues in India following a decentralized approach. The main objective of the project is to explore possibilities of combining Jokatsu technology with the algal bacterial technology that has been developed at IIT Hyderabad to effectively remove organic carbon, nutrients and micropollutants from wastewater under Indian conditions. Daiki Axis India has provided a pilot-scale Jokatsu unit to be used as a test bed. The test reactor is currently being operated in its basic configuration to collect the baseline data. Once the performance of this unit in removing organic carbon, nutrient and micropollutant is ascertained, algal technology will be integrated to improve the system's performance further. The microbiology of the Jokatsu system will also be studied.
This is the pilot scale Daiki Axis Jokatsu, which we use to treat the domestic wastewater at IIT Hyderabad. The inlet for the Jokatsu is taken from the equalization tank at the STP at IIT Hyderabad. It has 5 chambers. The first chamber is separation box and sedimentation tank. The inlet water first comes to the first chamber and the solids and liquid are separated using gravity. Second, it goes to the anaerobic chamber where anaerobic microorganisms treat the organic matter, and then it goes to the aerobic chamber where the process uses MBBR and the aerobic microorganism consumes the organic matter, and then it goes to the secondary sedimentation tank. The sludge formed in the MBBR goes to the secondary sedimentation tank and it is recirculated back to the first chamber to ensure the denitrification of the water. And at last there is a disinfection chamber where chlorine is used as a disinfectant, and the water at the outlet can be used for many purposes like gardening and flushing. The whole system is controlled using this PLC.
By integrating the algal technology with the time-tested Jokatsu technology, we will be able to provide a sustainable solution to the issues related to wastewater management. Thank you.
皆様、こんにちは。私はチェタニャと申します。本日は 5G 対応のワイヤレスポータブル ECG 心電図モニタリング IoT システム開発のプロジェクトについて紹介したいと思います。このプロジェクトは JICA フレンドシップ 2.0 リサーチ助成金で JICA からインド工科大学ハイデラバードに資金提供されています。また、このプロジェクトはインド工科大学ハイデラバードと日本のサイントラボ合同会社のコラボ開発です。主任研究者はインド工科大学ハイデラバードのドクター・ガジェンダナード先生です。日本側の共同主任研究者はサイントラボ合同会社から私、チェイタニアが参画しています。それではまず背景から説明いたします。21世紀のグローバル的に心臓病と脳卒中の死亡率が増えました。右側の図に示されている 世界銀行所得グループ統計データから、低所得、低中所得、高中所得、高所得、すべて国で心臓病と脳卒中の死亡率は上位を占めています。SDGs の目標ゴールでも3番目として、すべての人の健康と福祉を挙げています。様々な側面で ICT 情報通信技術は SDGs の達成に貢献しています。また、Society 5.0 の実現として IoT ワイヤレスコミュニケーションを利用して病院のサイバーフィジカルシステムを拡張して、またオペレーションコスト削減も目的として私たちは医療における IoT と無線通信を使って患者のバイタルサインを監視しています。提案システムは私たちの提案はエナジーハーベスティングを使ったウェアラブル IoT 監視システムを開発する計画です。このシステムは IoT 端末の上、機械学習とディープラーニングアルゴリズムを使って ECG 心電図信号のデータを処理して体の異常を検出することができます。提案したシステム概要としては、まずディープラーニングモデルにより ECG 心電図信号を分類します。あとはローパワー消費電力で AI 機械学習アルゴリズムをコンピュートできる IoT 端末の回路を開発する予定です。次に IoT メッシュネットワーク設計して 5G ネットワークインテグレーションします。最後的に患者の心電図、血圧、呼吸などの特性や実態を可視化するクラウドインフラを構築します。最近の実績として、Scient Labsは各種の環境空気指数を監視するために Bluetooth Low Power BME センサーモジュールと 5G エッジゲートウェイモジュールデバイスを開発しました。サイボードという IoT リアルタイム監視ポータルを開発して、環境指数の学習データを可視化して、オンボードの上に IoT デバイスの位置情報も表示することで、ユーザーの環境管理がリアルタイムできるようになりました。以上となります。プレゼンテーションをお聞きありがとうございました。何かご質問がございましたらお聞かせてください。
Greetings from IIT Hyderabad, India. We thank Friendship 2.0 Industrial Collaboration Research Grant 2023 for supporting this project entitled Development of 3.8 volt 30 ampere hour power type lithium-ion cells for electric vehicle, two-wheelers and three-wheelers especially. My name is Surendra Kumar Martha. I'm the head of the department and a professor at the Department of Chemistry, IIT Hyderabad. My expertise is material electrochemistry, especially for the development of materials for metal-ion batteries, lithium-ion and sodium-ion supercapacitors, recycling lithium-ion batteries. I have a group of 15 PhD students, 2 postdocs, 3 master students working on various aspects of this metal-ion batteries, supercapacitors, and recycling lithium-ion batteries. So this project is in collaboration with Mr. Shinichi Saito, who is the co-principal investigator of the project, who is the CEO of Fine Eco Solutions, Japan. The goal of the project is to produce 3.8 volt 30 ampere hour high temperature resistant lithium-ion cell for EV two-wheelers and three-wheelers. In this project, we plan to develop lithium-ion cells with an easy scalable approach for electrolyte development, sealing and testing commercial scale up. So once we are successful, we will plan to develop 30 ampere hour into 4, that is 120 ampere hour capacity modules. So once we are successful with modules, we may go for the development of battery packs, which is 48 volt 120 ampere hour battery packs actually. So in this project, we plan to develop this 3.8 volt 30 ampere hour high resistance lithium ion cells for EV2 wheelers and 3-wheelers. You may be looking why we need still lithium ion power cells. If you look at India scenario, not a single power type cell and a single lithium ion cell is produced in India today. This Friendship 2.0 industrial collaboration research grant will help us to develop lithium ion cells and batteries. If you look at our capabilities, our Japanese counterpart is developing this 30 ampere hour lithium ion cells, dry cells, especially for high temperature application, and they have studied some electrochemical performance at room temperature around 25 degrees centigrade. You can see here you have 60% capacity tension at the end of 4,000 cycles, and at 45 degrees centigrade, so we have 60% capacity tension at the end of 2,500 cycles. So the plan is that the Fine Eco Solutions and its collaborating agencies will help us to provide dry power cells and support for electrolyte formulation, advising us to run the project battery packs assembly, and finally we'll do a technology transfer. If you look at IIT Hyderabad responsibilities, IIT Hyderabad will help in electrolyte formulation, filling, formation, cycling, final sealing, testing, and cycling, making the deliverables. We have an industry partner here in Hyderabad, Rosen Energy Private Limited, which will, once we are successful with this cells, we may go for the battery packs, modules and packs, and battery management system. So IIT Hyderabad and Rosen Energy further will help in testing the battery packs, EV2 wheelers and 3-wheelers. If you look at the roadmap for the production of lithium-ion battery development at IIT Hyderabad, so in this project require 4 high-skilled technical persons. So one Fine Eco Solution is providing with us, and 3 manpower has been arranged at IIT Hyderabad. We have, if you look at the manufacturing equipments, battery cycler, electrolyte filling machine, electrolyte freeze, blow box are ready. Sealing machine, we are waiting. Once we are sealing machine is ready, we will start making the cells and testing the cells, so which is expected to start September 15, 2024, and it may take 6 months to 1 year to complete the project. So the dry cells, this 3.8 volt 30 ampere cells initially will be provided by Fine Eco Solutions. Will feed the electrolyte and seal the electrolyte, seal the cell with under vacuum, and then we will go for the formation cycle, then final sealing, then finished lithium cells will go for the cycling test and aging test. So finally we'll get 3.8 volt to 30 ampere hour cells, and we'll compare the performance with the existing systems. Once we are ready, then we may further approach our industry partner to develop a 48 volt, 3.8 volt, 120 ampere hour cells, modules and battery packs up 48 volts. So our industry collaborator, Rosen Energy, will help us in the system level development. In the past, beside this project, we have also organized one workshop, IIT Hyderabad International Workshop, on dawn of a new era for Indian automotive industry by creating new lithium-ion battery fits for the high temperature and promoting pollution-free EV world in India, which was organized in November 30, 2019. We expect to, once we are successful, we are going to organize a similar workshop in IIT Hyderabad as well. We believe with this in this project, we will be able to deliver a 3.8 volt 30 ampere hour cells, which is very important for Indian scenario. We thank JICA for the support, and thank you.
Hello everyone. I'm very glad to talk about our collaborative project on development of chemical admixtures for enhanced dispersion of chopped carbon fiber in cement composites. I am Professor S. Prakash. I'm working in IIT Hyderabad. My team includes master student Mr. Nihal Nagula and postdoctoral fellow Dr. Nikesh Tamishetty. in this project, what we are trying to do is to develop a good admixture, chemical admixture, in collaboration with a Japanese company called Floric. And in fact, it is funded by Friendship 2.0 project, which is one of the flagship project promoted by the Japanese government to initiate good collaboration between India and Japan. So in this project, we are trying to develop an admixture to disperse some discrete fibers that can be added to concrete. And concrete, as you know, it is very strong in compression, but it is very weak in tension. That means when I pull the concrete apart, it is going to crack. Now we have to arrest this crack. For arresting this crack, usually we add these discrete fibers, and such type of concrete is called fiber reinforced concrete. And we have different types of fibers that are readily available. Steel fibers is quite commonly used. We also have synthetic fibers. In this project, we are trying to see how carbon fibers can be used in concrete so that it can improve the mechanical strength, it can arrest the crack better, and it can also avoid shrinkage related issues in concrete. Now, there are some challenges when we add carbon fibers to concrete. And these carbon fibers have excellent mechanical properties. They're usually achieved by carbonizing organic fibers at a very high temperature, and they have very low diameter and very high aspect ratio, and they have excellent chemical resistance, corrosion resistance. They're extremely lightweight, and they also have very good electrical conductivity that can be used to advantage to make the concrete also conductive. And now this is just a picture of a carbon fiber. It's very tiny, and it also, as we discussed, it is going to help in reducing the shrinkage, improving the flexural properties, and it can also be used for smart material application because of its conductive nature. Now, there are problems related to dispersion of chopped carbon fibers. That is what in this project, with the collaboration with the Floric, we are trying to develop an admixture that will help in dispersing these chopped carbon fibers. And the challenges are related to the hydrophobic nature of this fiber. And they also have a very high aspect ratio. That means the length to diameter is very high. So it makes it very difficult to disperse them in concrete. And they also have strong interfiber. That means the fibers trying to attach to each other, and it's very difficult to separate them out. So different solutions people have tried in the past. That includes using some dispersion agents, and we can also use ultrasonification. And then there is a coating that is on the fiber. If you remove the coating on the fiber, that also helps in dispersing these fibers. And also we can do some pre-treatment to fibers. There are multiple ways with which we can disperse these fibers.
Hi everyone, I'm Nihal, a research student at IIT Hyderabad. I'm going to continue the discussion which was started by Professor Suriya. So as Professor Suriya said, the dispersion of chopped carbon fibers in the concrete is a major issue. So to improve the dispersion of the chopped carbon fibers, there are different ways, out of which the most effective ways are either adding a dispersion agent or using an ultrasonification mixing process. So now we'll discuss the mechanism of the dispersion agent. So when we add this dispersion agent to an aqueous solution containing carbon fibers, the dispersion agent is hydrophilic in nature, and they will form a thin layer on the surface of the carbon fibers. This is called a hydrophilic shell. This will increase the hydrophilicity of the carbon fibers and helps the carbon fibers wet with the water, and this will also create a steric effect which is they will have an repulsive forces between the individual fibers. So this will help in dispersing the carbon fibers, and the dispersion agent whatever we are adding will also increase the high viscosity of the solution, and this increase in viscosity of the solution will prevent any settlement of the carbon fibers after settling. So mixing procedure for dispersion of carbon fibers in the water. First we add the carbon fibers and dispersion agent and mix them using a mechanical stirrer for 1 minute. So this is a solution after mixing. Then we do a sonication process to the solution. That is, we'll send sound waves into this solution for at least 10 minutes. The sound waves will create a mechanical agitation in the aqueous solution, which will help in dispersion of these carbon fibers. So this is the final solution after sonication process. So after mixing, we have to measure the dispersion of the carbon fibers in the water. Which mixing method is best? So there are different mixing methods. One is manual stirrer and adding, second is adding dispersion agent and manual stirring, and third one is adding dispersion agent and using an ultrasonification mixing process. So out of these three mixing methods, the third one, it is showing that the dispersion agent plus ultrasonification mixing process is giving a better dispersion than the other two mixing methods. And in this settlement test, what we do is, after mixing, we measure the settlement of the carbon fibers in the solution after 30 minutes. And we also measure the spreadability of the solution. So in the spreadability test, we take a sheet of paper and pour the mixed carbon fiber solution on the sheet of paper. If the carbon fibers disperse properly in the sheet of paper, then the spreadability of the solution is very good. And as you can see, out of these three mixing methods, the dispersion agent plus ultrasonification is giving better spreadability than the other two methods. This is as same in the settlement test also. The dispersion agent plus ultrasonification mixing process will really help in dispersing the chopped carbon fibers.
Hello everyone, this is Dr. Nikis Tamesheti from IIT Hyderabad. I'll be continuing the discussion from Nihal. As Nihal was stating in the previous slides that there are different dispersion agents which can be used for proper dispersion of carbon fibers in aqueous solution. As part of our research, we have used sodium hydroxide and hydroxyethyl cellulose, which is HEC, and carboxymethyl cellulose, CMC. So we have prepared all the mixes using sonicator, and from this comparison we can see that the mix in which we have used CMC as a dispersion agent, we can see that it is working better than the other dispersion agents. So taking this into account, we have gone for the preparation of some cement mortar specimens where we have used CMC as dispersion agent, and we have used different fiber dosages to see the efficiency in increasing the compressive strengths. So here I'm showing the compressive strength results of mortar specimens which we have prepared, and in the first case we have used 0.3% CMC by weight of binder, and we have gone for increasing the chopped carbon fiber percentage from 0.1 to 0.3, and we can see from the results that in the case where we have used 0.3% CMC, the highest compressive strength was found to be when we have used carbon chopped fibers of 0.2%. Whereas when we have gone for CMC of 0.5%, we have seen that amount of the increase in compressive strength was high for 0.2% and 0.3% of chopped carbon fibers. So based on these preliminary results which we have seen here, we started to work with Fluoric, international Fluoric company from Japan, which is one of the leading admixture producers in Japan. So we are working on developing different products. One of the product will be a dispersion agent or an admixture which can work as a dispersion agent for carbon fiber reinforced concrete. So this is this photo was taken during my visit to Fluoric. So this is one of the state-of-the-art facilities which Fluoric has developed for getting the temperature in the specimens, in the mortar specimens while they are being air cured. And this is the viscosity measuring device which we have used for knowing the viscosity of the CMC liquid. And in this case, we are showing the HPMC as a dispersion agent, and we have seen that even HPMC is also working well as a dispersion agent. And on these lines, we will be continuing the research further, and we'll be developing a new product for this. Thank you. We can be reached at suryap@c.iith.ac.in. Thank you for this amazing opportunity.
いかがでしたでしょうか。本大学との連携を選択肢の一つに加えていただければ幸いです。 また、こんな研究はしていないかといったお問い合わせなども大歓迎です。ぜひ、Next Generation Park のブースへお越しください。お待ちしています。それでは本日のインド工科大学ハイデラバード校 IITH のセミナーにお越しいただきまして大変ありがとうございました。厚くお礼申し上げます。どうもありがとうございました。